Here are the answers for review 3.1 through 3.3 and 3.8 Form B, the second part of our review day. In this first set of problems, if you can name the angles, do so. So we're going to name them. That's the first thing we're going to do. We're going to identify a transversal if one exists, and we're going to state whether the angles are congruent or supplementary, or that there's no conclusion. And they told me that line A was parallel to line B. So we're going to look at angle 8 and angle 4 to start with. Angle 8 is here. Angle 4 is here. These are same side interior angles. They are formed by A and B, and the transversal would be C. That's the second part. And same side interior angles would be supplementary. Angle 2 and angle 5. They're formed by line A and B and D. D ends up being the transversal. 2 and 5, they're both on the right and on the top of the transversal, so they are corresponding. And because they are corresponding angles, they would be equal since A and B are parallel to each other. 7 and 11. Again, formed by line A and B and line C cutting through them. They're both on the outside of A and B, and they're on opposite sides of line C. C would be the transversal. They are alternate exterior angles, and they would be equal. Nine and 11. Angle 9, angle 11. Angle 9 and angle 11, they're both on kind of the bottom of the line C, and they're both kind of on the bottom of A and B, so they're the bottom and kind of maybe the left side of line C. So they hold the same corresponding spot. Line C is the transversal, and they would be equal because A and B are parallel to each other. 2 and 12. They're both on the inside of A and B, and they're on opposite sides of line D. D would be the transversal. They would be alternate interior angles, and they would be equal. 3 and 10. Angle 3 and angle 10 have nothing to do with this other line. They're actually both formed by these two intersecting lines. They are across from each other. They are vertical. They would be equal, but they would not have a transversal. When you get a problem like this, make sure that you mark which they've told you are parallel, because that helps you determine which angles can be equal to each other. So A is parallel to B and L is parallel to M. They told me that angle 1 was 130 degrees. And they told me that angle 9 and angle 10 were actually equal to each other. So I've marked those two as being equal. And I really would just encourage you, just go through and try to figure out the pieces that you do know. If angle 1 is 130 degrees, then I know that angle 1 and angle 2 have to add up to 180. So if I took 180 minus the 130, this would be 50 degrees over here. Since this is 50 degrees, these two are alternate interior angles. This would also be 50. This would be vertical to angle 3 or corresponding to angle 2. This would be 50. Angle 6 and angle 12 would be alternate interior. This would be 50. Angle 14 would also be 50. There's some other angles that are easy then to find. I know that if this one's 50, that this one has to be 130 and 130. And it means this one is also going to be 50 because it would be corresponding. Now, the other ones that are here might be a little harder to see, but I do know that 9 and 5 would be congruent. And if 9 and 5 are congruent, 10 and 4 are also congruent. And that means that they're also congruent to 7 and 8. So I do know that 9, 10, 4, 5, 8, 6, all going to have the same measurement. Now, if I take a look, the measure of angle 9 plus the measure of angle 10 has to be equal to 130 degrees in total. But because these two have to be the same, if I let them both be x, 2x would be 130. And if I divide both by 2, x would be 65. Which means each one of the missing angles yet, because they are all equal, are in fact 65 degrees. In this problem, they asked me to find x and y, and they've shown that these two lines are parallel. I do know this though, y minus 1 plus 35 has to be equal to 180 degrees. Nothing to do with parallel lines. This is a linear pair. Y plus 34 equals 180. And so I'm going to subtract 34 from both sides. And y is going to be equal to then 146, I believe. If y is 146 degrees, then this angle is 145. And I really do like to just go around and fill in the pieces that I know. 35, 35, 35, 35. All the others have to be 145. And one of the reasons that I like to do that is it will write in the other equation that I need. 3x plus 1 equals 145 degrees. If I subtract 1 from both sides, 3x then is equal to 144. And if I divide both sides by 3, I get x equals 48. So x is 48, y is 146. I'm going to kind of do the same thing here. I'm going to look to see where I might be able to set something up where I know that two things are equal. X minus 5 and 42 are alternate interior angles. If they're alternate interior angles and the two lines are parallel, then these two would be equal to each other. I'm going to add 5 to both sides, and I'm going to get x is equal to 47. Now, if x is 47 degrees, and I take a look at what's left here, okay, this angle, the whole thing, and this angle, the whole thing, would be same side interior angles, with this line being the transversal. They're both on the inside of the lines. They're on the same side of the transversal. So I have to add all the pieces together. The 42 plus the 3y plus 2 makes up this top angle. The 28 makes up the bottom angle, but when I add all those pieces together, it should be equal to 180 degrees. Combine like terms, 42 and 2 and 28. 3y is plus 72 is equal to 180. Subtracting 72 from both sides, 3y then is equal to 108. And so when I divide by 3, I get y equals 36. On these, they asked me to find the value of x so that these lines would, in fact, be parallel. They didn't start out with them being parallel, but they want to force them to be parallel. So corresponding angles would have to be equal, and that would give me my equation. 2x minus 3 equals 135. Add 3 to both sides. 2x would be equal to 138, and divide both sides by 2. X would be equal to 69. When I'm looking at this problem, if they want to force these two lines to be parallel, this would have to be 103. And the other angles then would have to be 77. And you can see that there would become my equation. 2x plus 7 has got to be equal to 77. Subtract 7 from both sides. 2x would have to be equal to 70, which means x would be 35. In this problem, these are alternate exterior angles. They would be equal to each other. 3x minus 2 would have to be equal to 136. Again, if you wanted to fill them in, you could see these are vertical. These are alternate interior. These are vertical. There's my equation. Add 2 to both sides. 3x equals 138. And divide both sides by 3. X would be 46. Taking a look at this problem, this is x plus 4. This would also be x plus 4. This is 2x minus 1. These two angles would be 2x minus 1. These two angles now are same side interior, so they should add up to equal 180 degrees. 2x minus 1 plus x plus 4 should be equal to 180 degrees. This would be 3x, combining like terms, plus 3 equals 180. Subtract 3 from both sides. 3x would be equal to 177, and divide both sides by 3. X would be 59. And I think we'll have to go back and change the answer to number 13 on the main sheet. It said x equals 5, but x is 59. These are same side interior angles. These two should add up to equal 180 degrees. 6x plus 3 plus 8x plus 23 should be equal to 180 degrees. Combine like terms. 14x plus 26 equals 180. Subtract the 26 from both sides. 14x is equal to 154, and divide both sides by 14. X would be equal to 11. Here it said both lines are parallel. So these two lines are parallel, and these two lines are parallel. And so if this is 2x plus 47, I'm just going to go through and mark the angles that would have to be the same. All of these would be 2x plus 47. Likewise, coming this way, this would be an alternate interior. Those would be the same. There's the two that I'm going to set up equal first. You can see that 2x plus 47 has got to be the same as 6x plus 43. So I'm going to set those equal. I know that it would be equal also to this 2z plus 9, but I would have two variables. This only has one in it, so I'm going to solve this first. I'm going to go ahead and subtract 2x from both sides. I now have 47 is equal to 4x plus 43. Subtracting 43 from both sides. I have 4 equals 4x. And when I divide by 4, I find out that my x is equal to 1. I'm going to plug that back in. 2 times 1 plus 47. 2 times 1 is 2 plus 47 is 49. So each one of these angles that I've marked would be 49 degrees. You can see there's another equation. 2z plus 9 equals 49. Subtract 9 from both sides. 2z is equal to 40. Divide both sides by 2. Z is equal to 20. There's two of my answers so far. If this is 49 degrees here, these two angles put together would have to add up to 180. So the angle that's remaining would be 131 degrees. And that would become my third equation. My third equation would say 3y minus 14 equals 131. Adding 14 to both sides, 3y would be equal to 145. And when I divide both sides by 3, I'm going to get y is equal to, it comes up to 48 1/3, or 145 over 3. You could have left it that way as well. Either would be okay. This is another problem where you just have to kind of work around the picture, make sure that you've put in the given information. They said angle 1 was 125 degrees. If angle 1 is 125 degrees, to find angle 2, these two would have to add up to 180. 180 minus 125 would in fact then be 55 degrees. So angle 2 would be 55. 2 and 3 are alternate interior angles. This would be 55 degrees. Because these two angles have to add up to 90 in this corner, I know that I've used up 55 of it. That means that the angle that's remaining would be 35 degrees. Because this is 90 here, this would also be 90. Okay. Because this one was 55, angle 2, angle 7 would also be 55. And again, these two angles up here would have to add up to 90 degrees. If this is 55, this would have to be 35. If this one's 55, alternate interior angles, this one would have to be 55. And to find the one that's out here on the outside, I could take 180 minus the 55 degrees. And 180 minus 55, this is going to be 125 degrees. If I'm writing an equation of a line that's perpendicular to this, the slope of this line was 3/2. To be perpendicular, it has to be the opposite or the negative reciprocal. So my slope now has to be a negative 2/3. So if it goes through this point, 3, -5, and has a slope of negative 2/3, in y equals mx plus b, I can replace y with -5. I can replace m with a negative 2/3. I can replace x with the 3, and I can use this information to find b. -5 equals, these would cancel out, -2 plus b, adding 2 to both sides, b would be equal to a -3. If my slope was a negative 2/3 and my y-intercept was a -3, remember that when you're writing something in this form, slope-intercept form, all I have to do is replace m and b. Y equals -2/3 x minus 3 would be my equation. This one's a little peculiar, but remember that if you have an equation that says y equals 3, that what you actually have is you have a graph that is horizontal, that is actually 1, 2, 3 units above the x-axis. If it's going to be perpendicular to it, it would need to be vertical. This is horizontal. To be perpendicular, it would need to be vertical. All vertical angles are set up x equals to some number. And since it has to go through this point, -4, -7, which would maybe be down here somewhere, the x value is the part that I need to know. X would have to be -4. There's the equation of the line. This would have a 0 slope, this would have an undefined slope, these would be perpendicular to each other. Here they ask me to find the slope of this equation, which is written in standard form. I'm going to take what was written in standard form and change it into slope-intercept form by solving this equation for y. I have to get y by itself, so I'm going to get rid of the 2x. Don't forget the negative that's attached to the 3y. And I'm going to divide each individual term then by a -3. I have y equals, a negative divided by a negative would make a positive, and a positive divided by a negative would make a negative, but the part that I'm really interested in is right there in front of the x. The slope of this line would be 2/3, and if it's going to be parallel to this, it would also be 2/3. Determine if line AB and CD are parallel. So I'm going to work out number 20 over here. I'm going to work out number 21 down here. Slope of AB. Remember that the slope formula says y2 minus y1 over x2 minus x1. y2 minus y1, 19 minus a -9. x2 minus x1, 8 minus a -6. Both of my minus negatives change into plus positives. I now have 28 over 14, which is 2. Now I'm going to find the slope of segment CD. y2 minus y1, 0 minus a -4. x2 minus x1, 2 minus 0. Minus a negative changes into a positive. This would be 4 over 2, which is 2. Because these two slopes are in fact identical, these would be parallel to each other. Same process for number 21. The slope of segment AB. y2 minus y1, 1 minus 5. x2, negative 3, minus x1, 1. 1 minus 5 is a negative 4. Negative 3 minus 1 is a negative 4. This would be a positive 1 for a slope. Slope of segment CD. y2, 8 minus y1, 0. x2, negative 10, minus the 6. This would be 8 over a negative 16, or a negative 1/2. Since these are not the same, and they're not negative reciprocals, this is neither parallel nor perpendicular. Now we did have one that we had to go back and change. Number 13, x equals 59. So I'll put this back up here. Number 13, we said x equals 59. So make sure that we make that change on your answers.